All right, guys, welcome to first part of Unit 3, Managing Virtual Environments. So let's get into it. Besides my name flying in on screen here, just a quick heads up. I'm recording at work right now because I'm working 10-hour shifts up until Thanksgiving because they need me to cover someone in the evening. So it's about 4:30. I'm going to go home for about another 4 hours. So I figured, hey, let's record some stuff for Thanksgiving break. The assignment should be posted by now. I'm not having you guys doing labs this week. It's Thanksgiving. I will make a discussion. Don't worry, it won't be anything crazy. It'll essentially be free points, just like reply. That's all I need from you guys to do for that part of the discussion board. But the assignment will be simple. It's only 2 papers. Don't worry, I'm not going to make you write like a whole law book of stuff here. Let's get into it. So what are we covering here right now? We're going to cover resource allocation and optimization. It's all about virtual machines, right? Virtual environments, okay? So don't worry. Snapshots and cloning, what's the difference? Snapshots, clones, VM templates, and provisioning. And last but not least, I will get into virtual networking a little bit and storage, but the second half of this Unit 3 here has more to do with virtual network. So dive a little more into that. So resource allocation optimization. What is virtual machine resource allocation? So you guys have already done this essentially. When you guys set up your machine, you may have copied the setup. I have given you half of my RAM, 50 gigs of hard drive space, how many cores they give it, et cetera, et cetera, et cetera. That's essentially what you're doing is allocating your resources of your host machine. But how much is too much is what you have to figure out. Well, if you're doing this for like 8 machines on one tower, for example, it's only like an 8 core. How many cores are going to get? 1 core. So we got 64 gigs of RAM. How much RAM would you get per machine? 4 gigs, 8 gigs, things like that. These are things you got to figure out. But here's the definition of resource allocation. It is the process of figuring out the best way to distribute limited resources between multiple applications. Virtual machine resource allocation is this same task, determining how to best divide VM resources between the VM present in your network. Effective resource allocation will ensure all VMs complete jobs successfully and without draining excessive resources. I mean, the PC is the finite resource, guys. It can burn out over time too, right? Anything can happen. It's an email, not important. Virtual allocation is the act of provisioning virtual machine processors onto physical hosts or cores, such as your CPU, to increase network facilities and opportunities. Weird way of wording it. Enacting proper virtual machine resource allocation will help you distribute operations fairly among virtual machines used for virtual allocation. Makes more sense that way. Virtual allocation may seem like a dream come true, but keep in mind, virtual machine resources allocation often leads to optimization problems. More virtual machine processors means more connections within your network, which increases the number of simultaneous occurring operations. The more operations going on at once, the higher your chances of latency, bottlenecks, and other performance issues. Latency is just a fancy word for lag, guys. All right, let's on to the next slide, but let me pause this for a sec because I actually need some water, so give me a second. All right, took off my sweater too because it was overheating. Let's just talk about establishing baselines. So the full version I want to talk about to the right, and the really simplified versions on the left for you guys to read. I'm not going to read the left one, obviously. Baselines are generated by collecting data on virtual machine resource workloads, tasks, and applications used over time to juxtapose current performance metrics to previous performance metrics of similar qualities. So essentially, you're taking your current virtual machines and comparing to your older virtual machines to see if they're working at the same rate, if they're working faster, or they're working slower. That's just a fancy way of saying that. Or reports, how were they last month compared to this month? This will help you understand how individual virtual machines are performing at a particular moment as compared to previously, and how effective your virtual partitioning process is currently versus how it was in the past. Literally what I just said in simpler terms, hopefully. Praying I haven't lost some of you right now. Constantly monitor virtual allocation. To ensure optimal virtual machine resource allocation, you should consistently check on the performance of your virtual machines and your virtual machine resources. VM is virtual machine, guys. You should know that by now. This will help you keep up to date how many virtual machine resources are in use at a given time, along with which virtual machine they're allocated to. Think of this more like if you had like a server farm, you're like making your own cloud storage for some reason in a company and want to use outside resources. You would virtualize more than half of it easily, right? Saves money, so you need less footprint, et cetera, et cetera. But you have to have monitoring software in place. I'm not going to get into that here. You can go down deep the rabbit hole. Let's put it that way. And you can see how much RAM is being used at one time, how much hard drive space is being used, blah 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 blah, all that stuff. So, anyway, Investing in a virtual machine resource monitoring tool, which I literally just mentioned about monitoring tools. Virtual machine resource allocation tools are designed to help uncover and understand critical information about your virtual machine resources, how they're allocated and used, the health and functionality of your virtual machines and hypervisors themselves, and other essential virtual allocation metrics. So moving on, let's get into optimization. This is all about allocation, right? So optimization. What influences virtual machine performance? Virtual machines are run as user space processes on the host, right? Because you set it up, how much hardware space are you using, how much RAM space do you want to give it, how many cores you want to give it, et cetera, et cetera. The hypervisor therefore needs to convert the host system's resources so that the virtual machines can use them. The impact of virtualization on system performance. It's bold. If anything's bold, guys, it's for a reason, and it's sticking out. It's not just so, oh, I just decided to put bold in the middle or something. No, this is pretty important. That's why it's bold. Virtual CPUs, vCPUs, are implemented as threads on the host handled by the Linux scheduler. VMs do not automatically inherit optimization features such as NUMA or huge pages from the host kernel. It's getting very techy. I do apologize. So essentially, it's saying that pages are a kind of a Windows page. If you ever heard that, if not, it's the first time, congratulations, is what Windows sends out to try to figure out what it's trying to do, and back and forth, back and forth. It's just like a big moving part of Windows. And it doesn't necessarily inherit that. It inherits something smaller. It still acts what's called as a paging file. It's just on a smaller scale. Disk and network I/O settings, which you guys should have changed by now if you're using your bridge ones. That's what that's referring to. Input/output settings, I/O. Of the host machine have sufficient performance impact on the virtual machine. Network traffic typically travels to virtual machines through a software-based bridge, which you guys have set up, which is how you guys were able to ping back and forth. I know some of you had to enable file and share settings. If you're still having problems with that, again, message me, we can figure it out. Depending on the host device and their models, there might be significant overhead due to emulation of particular hardware. So remember, when you set up a virtual machine, you're setting up everything virtual. Like the graphic card, for example, currently sees it as a 128 megabyte graphic card, which is fine. You don't need much, video power. But what if you wanted to, I don't know, do video editing in a virtual machine? Excuse, how much more virtual video memory would you need? A lot more. So again, that's what it's saying about overhead and emulation, because you're emulating all these functions. They're not real. They're virtual, right? Because the machine is not a real machine. It's a virtual machine. If you haven't heard of Russian nesting dolls, that's essentially what you're making. It's doll within a doll within a doll, and the doll it kind of gets smaller and smaller. But for terms of machine, you could have one or two virtual machines inside your own machine, and you're fine, depending on how your system's built or what you have built in. But for example, for some of you that I know are running on somewhat more not ancient hardware is not the word I'm looking for, more just limited capacity because of space or whatever, what have you. You kind of have to figure out, how big of a machine is this going to be? Do I want to give it 2 cores, 1 core? Do I want to give 1 gig of RAM, 2 gigs of RAM? My suggestion is 2 normally, but it can be pushing it depending on your system. So you have a minimum 8 gigs of RAM, you're not going to spin up more than 2 virtual machines, I guarantee you. Anyhow, that's just how I'm thinking in terms of like overhead or emulation. So keep going on optimization here. Severity of the virtualization's impact on the virtual machine's performance is influenced by a variety of factors, which include the number of currently running virtual machines. So if you can only host 2 virtual machines, you run 3, including your home machine, your host machine, that's 4 items you're running. That's a pretty big tax on your machine. It might even cause it to crash. I have seen that happen. The number of virtual devices used by each virtual machine, the devices types used by virtual machines, reducing virtual machine performance loss. But why do we optimize? Windows was designed for physical hardware, specifically desktops, and for that, hardware to be accessed by just one user at a time. Windows uses many resources to present a responsive desktop, but many of its settings are necessarily or even detrimental when applied to a virtual environment. So it's not that the virtual machine is going to struggle to run on Windows, but it's not exactly designed for it, is what it's saying. So moving on. Guys, this is only about 22 slides. Each part of this unit is about 20 plus slides. It's not too much. So what are you optimizing? Optimizing virtual desktops. Here's how you optimize. Here's why you would optimize them, right? You increase their performance, increase their density, boosting the number of virtual desktops that can be hosted per vSphere. I just grabbed some vSphere information that I had laying around. vSphere server, sorry. Therefore, reducing infrastructures. I will fix that spacing, I promise. Improve end user experience, reduces end user support incidents. So the more optimized you have, the more fine-tuned it's running, the less problems you're going to have, essentially. So why would you optimize servers? Increases hosted desktop and application performance. Cool, so it runs better. Reduces the amount of system resources that each server requires, so it's using less space and less memory, which is even better. Increases the number of servers that can be hosted virtually on Windows Server 2016, 2022. It's just the latest version. Keep in mind, 2016 is no longer supported. I believe they're only supporting up to 2018 R2. So I just use 2016 because it's free and you guys can get download for free. And one day if they were taken away for free, I will still have a copy of it that my future clients can use for free. That's how I see it. And what better way of learning old tools like or old systems are no longer supported? You can break it, and you're not going to hurt anything. Anyways, increase the number of users that can be supported per server. Improve the end user host desktop and application experience. Reduce system support incidents. Sorry about that, guys. That spacing was bothering me, so I fixed it. So there it is. On to slide 8. When do you optimize? The traditional approach to optimizing virtual desktops or servers is to use a master image. Well, what the hell is a master image? A master image is the main image you use to deploy on all of these virtual machines. So you know how you had that copy of server? So you customize it, you tweaked it, you turned on some settings, made sure it only has, I don't know, 2 built-in users that can log in. You made sure it turned on some extra services and windows in there that you need. Then you would make that what's called the master image. You make a copy of that, a real main copy that you can deploy across to a bunch of other servers. So that's an example of how a master image goes. Usually called bare metal as well. You apply optimizations to the master image, which is used to create a desktop pool. You can only use a master image to deploy multiple servers. I fix that spacing. Hold on, I'll fix it after. Another type of optimization that is frequently performed is one that is made simultaneously to remote systems. Oh, Lord, that spacing is wrong too. The kind of optimization is often performed to tune something that was not optimized when the system was first deployed. So you gotta play catch up sometimes. You discover things as you deploy things too. So give me 1 second. All right, fix the slide. That's way better. Moving on. So we're done with optimization. And let's go into snapshots. So a snapshot picture, right? Picture of a point in time, which isn't exactly the whole picture. It's just a certain picture of, right before you do an update, you'll make a system restore point or snapshot, not a full clone of the system. A snapshot is a point in time image of a server instance or a computer. Same thing, you can do that in Windows. What does a snapshot contain? A snapshot of an instance includes a point-in-time image of all the block storage volumes attached to the instance except the boot volume and backup volume. Okay, pretty straightforward there. The snapshot reflects the state of the volumes at the time when the creation of the snapshot is triggered. Changes to the volumes after that point in time won't be included in the snapshot. So again, that's like before a big update to Windows, you take what's called the system restore point or a snapshot of the system. So in case you push out, let's say you push out Windows, you have Windows 10 or 11, whatever. Let's say you just deployed the newest update is now 24R1. You install, but right before you install 24R1, Windows itself makes a snapshot of itself. So, hey, this was right before I did it. You install 24R1, you boot into Windows 10, you log in as yourself. Windows 11, you log in as yourself. You go to hit start, you go to launch Chrome, you go to try to launch Steam. I'm old. Well, you try to launch Epic Game Launcher, and then you click on your favorite game and it just crashes. You get a blue screen. Well, crap, what could have caused it? It could have been this, it could have been that. Well, I just did a major update to Windows. I installed 24R1. Let me go to my system restore point when on the reboot, because you can still get into Windows, right? Hopefully. Go into your reboot, you launch into Windows, go to system restore, which I can show you what it looks like. I typed system, that one. Sorry, guys. I'm on my work machine, so things are a little different here. So it's now called recovery. I still call it restore point from many, many days ago. That's what it looks like, right? So we'll go to here. I'm like, all right, the last update I did was on yesterday. It's pulling up the system restore. Here's what that looks like. I know I'm segueing out of it just so you guys can see it. See? Install management. That's something I use at work to remote in the machines. But this is the one I want. Like, it broke after this day. So let me just hit next and we go through the motions of the ocean. And it pushes it back to before the update was pushed. So what happens when I create a snapshot? The instance that you're taking a snapshot of continues to be available when the snapshot is created. The instance is in maintenance mode, which means that you can't perform administrator operations such as patching and backup. While a snapshot is being created, the applications can continue to access the storage volumes. It's just straightforward. Let's talk about what is a clone. That's not the clone I'm talking about. A clone is a replica of the original instance. I just put that in there as a joke. I hope you're laughing. If not, you're probably thinking this guy's pretty lame. What does a clone contain? An exact uncompressed replica of an entire drive or specific partitions. Since clones are uncompressed, which means they're not shrunken down, they can be immediately replicated to the target backup drive or the cloud, resulting in an up-to-date identical copy of the data. Hopefully that made sense. It's just a big main copy of it. Here's what that looks like. Ignore my Star Wars clone there. Snapshots and clones. How does cloning work? A clone created from a snapshot inherits certain attributes of the original instance. You can override some of the attributes as you specify a few attributes, as you must specify, sorry. The following diagram, this guy here, which I found online, which is a very beautiful picture that explains it. And I'm going to talk about it right now. Shows the relationship between snapshots and clones. In this example, multiple snapshots of instants are created on different dates. So on these dates, November 1st, 15th, and December 15th, we made snapshot A, snapshot B, and snapshot C. Right? That's what it's saying. Some of the snapshots were used to create multiple clones of the parent instance. So we created a clone of instance 2, instance 3, instance 4 on that day. On this day, we created clones of instance 5 and instance 6. When you were accessing the machine, you're doing whatever. It's called an instance. There you go. Straightforward, guys. Hopefully it's not too dicey and that made perfect sense. Obviously, on the November 15th, we're like, we're not going to clone nothing. Why? I don't know. Was it cool to clone that day? It was not National Clone Day? I don't know. Anywho, so let's talk about templates and provisioning. We're moving on now. Manual deployment of similar VMs on large virtual environments can be a boring task. Well, yeah, it's pretty dry to set up a machine all the time. So that's where templates come in. What is a VM template? A VM template is a master copy image of a virtual machine that includes VM disks, virtual devices, and settings. So that's like taking your server that you have right now, your Windows 10 machine, whatever machine you want to make, even Windows 11, it's fine. And you just push that out to every virtual machine you have on the network. That's where the template will come. Instead of you going by just like, oh man, let me plug in this flash drive and copy it over. Oh man, let me copy this flash drive. Let me use this flash drive, copy it over constantly all the time. Just doing your network and just make an instance of it through vSphere and just push it. Like, hey, machines X through Y, just using them as variable pool, 1 through 50, all have to have this image. Go! And it just does it. And then you're ready to rock and roll. The template can be used many times over for the purposes of VM cloning. You cannot power on and edit the template once it has been created. Once it's set in stone essentially when you started it. Unless you destroy it for some weird reason. This is by design, so nobody can accidentally edit the virtual machine that is used as a template. Ta-da! Pretty straightforward, right? Nothing too crazy. So preparing a VM for template creation. So when you have a virtual machine, you want to create a template, here is what you do. I'm not going to have you guys do this, unfortunately. It takes up too much space, and I don't want you guys to go through the headache of running out of hard drive space, because I know I'm not the only class you're taking. So, and if you're in my server class, this doesn't overlap. Some of the labs we do in here do overlap a server at the end too, because they just go hand in hand, guys. It's just how it goes. So creating a new virtual machine with sufficient CPU, disk, and memory resources, select the appropriate VM compatibility options. So it's like you set up in a regular VM, right? How much RAM, how much hard drive space you're going to give it, how much CPU power you're going to give it. Disconnecting unused devices from a virtual machine, disconnecting unused devices from a virtual machine, it's pretty straightforward. If you're using a virtual machine that already exists, disconnect unnecessary hardware devices such as virtual floppy drives, virtual COM controllers, COM's an old thing, LPT controllers, etc. Oh god, communication port. You got half of you don't even know what that even before, so you won't know what a communication port is. Heck, I can't guarantee you somebody doesn't even know what parallel or serial even looks like. Yes, I'm dating myself, but don't get me started. I am older than Google. I've said it like twice now. Install the required software on a virtual machine. Install the operating system on the virtual machine. Then install the necessary updates, security patches, antivirus protection, and specific software needed for your purposes. What if you're making a machine for accounting? What do they need? Office, cool. Virtual antivirus, done. QuickBooks, done. Now give them all virtual machines. Problem solved. Save the company thousands of dollars. You're a hero. I think, maybe, possibly. Installing virtual virtual malware. Sorry guys, I was thinking about my security stuff. Installing virtual VMware tools. VMware tools. God, I feel like an idiot. Tools is a set of drivers and utilities that increases the performance of guest OSs running on a virtual machine, as well as facilitating virtual machine management. Just tools, tool set, pretty simple. Might look into us installing that later if I get a chance. Removing unwanted software components on a virtual machine. You can make your virtual machine template more lightweight by optimizing the guest OS. So what if you have this template you made, but you made it and you have like a bunch of software like Bahaba blockers, I'm trying to think of other stuff. Just a bunch of free software. You like, what if that person doesn't need it, or if that area of the company doesn't need it? Just get rid of all that. Make a new one with really baseline and simple and streamlined. That's what that's referring to. Just I can't think of any free software you would download and use, and I'll see right now in my head. Can't think of anything. If I think of anything, I'll add it in the future. So let's talk about virtual networking and storage. We've got like 8 slides left, guys. We're almost there. So far, this has only been an 8-minute lecture. I am a little terrified. But, I mean, hey, it's Thanksgiving, guys. I just hope you're enjoying it and not just hearing me yak and talk all day here. Virtual networking, this is going to be a headache. I do apologize. Enables the communication between multiple computers, virtual machines, virtual servers, and other devices across different offices, it's fine, and data center locations. So pretty straightforward, right? You use virtualized versions of traditional networking tools like switches and network adapters, which we have played with in the sense I've had you Convert from NAT to bridge. That's a virtual adapter. Allowing for more efficient routing and easier network configuration changes. Okay, yeah, we did some changes. We made it live, right? So you can ping it and remote into it and stuff. Virtual networking enables devices across many locations to function with the same capabilities as traditional physical networks. Well, yeah, because you're emulating a physical network. It's, pretty straightforward. It's just, again, it's like Russian nesting doll syndrome, a switch within a server, within this, within that, blah, 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 blah. Here's a diagram. Enjoy. And if you're wondering what decoupled means, I will tell you right now, it just means they're not joined. The hypervisor and the network virtualization platforms are not connected. That's all it means. I'm pointing at it. I know you can't see it, but it's, in essence, that's what that's talking about. All right, then. How does the virtual networking work? A virtual network contains virtual machines, VM1, VM2, VM3. No matter, connects virtual machines and devices, no matter their location, using software. Essentially, yes. In a physical network, layer 2 and 3 functions of the OSI model happen within physical switches and routers. Plus, physical network interface cards, NICs, network cards for short, if you want to call them that, and network adapters, like wireless adapters, are used to connect computers and servers to the network. Pretty straightforward. Virtual networking shifts these and other activities to the software. So you're emulating all of this above you, essentially, except I think the OSI model. And here's the thing about the OSI model, guys. I don't know if I mentioned it in the lecture or not, but I will tell you now. The OSI model is more sense used as a point of reference. I don't hear I troubleshoot stuff and fix things, look at servers and all that jazz, right? You may have heard that from me before. If I go to a room and the computer's not getting a network, like, oh, we're in the OSI model. Would I go fix this right now? Let me climb the ladder in this building and go into an access point hatch or whatever. I look at what's called an idea of a big cabinet of switches. Let me figure out what OSI model that is in there. No, it's more like, okay, where's the issue? Is it not talking to something as the name of your computer not being converted to an IP? That's DNS error. Things like that. That's what you use the OSI model for. It's not just let me go look up the OSI model on my computer so I can point to. No, it's just a frame of reference. You understand where everything goes and what it does. It can be big and confusing and annoying, but once you practice with it enough, you figure out like, oh, well, is the issue on layer 1, layer 2, layer 3? Is it a physical issue, a virtual issue, things like that. That's what the OSI model is for. Segueing back into this, just try to clarify some of this. Hopefully it's not as clear as mud. Anyways, a software application called the virtual switch or vSwitch controls and directs communications between the existing physical network and virtual parts of the network, like virtual machines, virtualizing your switches. Pretty straightforward. And a virtual network adapter allows computers and VMs to connect to a network, including making it possible for all the machines on a local area network to connect to a larger network. Straightforward. That's essentially what it does. So moving on. Advantages of virtual networks. Streamlines the amount of networking hardware, cabling, switches, etc., endpoints, fiber optic cables, all that stuff, by shifting many functions to software. Cool. Reduces the cost and complexity of managing network hardware and software through centralized controlling. Yeah, it's cheaper. Offers more flexible options for network routing structures and configuration, including easier options for segmenting and subdividing the network. Remember, sometimes you have to subdivide because, like I've told you in the prior lecture, I believe, would accounting need access to stuff from HR? Maybe for like sending a paycheck, but would they need access to stuff from, try and just think of something. If you have a security office, no, I don't think they need to look up crime reports. Maybe they look at like if stuff was stolen, money wise, yeah, they would file a separate report, but they wouldn't be on the same network as security for that reason. I mean, like security guards. I'm not talking about like IT security. That's a different animal. Improves control over network traffic with more fine-grained options like configuring firewalls at the virtual NIC level. Just tailor things more essentially. Increase IT productivity through remote and automated service activation and performance testing. Well, yeah, you're going to test everything before you can deploy it, right? You just put it all nilly-willy in the wild and then watch it catch fire and you're like, oh man, how am I going to fix this? No, you test everything before you deploy it. Boost business scalability and flexibility by enabling virtual upgrades, automated configuration or configuring, and modular changes to network appliances and applications. Pretty straightforward stuff. Let's move on. Some disadvantages. How could you have any disadvantages if something isn't real? Well, it's a new skill for IT staff. Not everyone's versed in networking. I get it. Not everyone's versed in virtual networking. It's a little more deeper. This is one of the major challenges, new skills for IT staff. Major challenges faced during network virtualization. The staff needs to be trained and experienced in handling the shift to virtual machines. Since the system is no more their traditional standard system, it needs to be operated, maintained, and designed differently, which needs a different set of skills altogether. You gotta get your hands wet with this stuff. It's hard at first, but you can master it. You can make very good money being just a network engineer implementing virtual networks, physical networks, all that jazz. It's a lot of thinking. I'll tell you that. It's a lot of problem solving, but not the kind of problem solving you and I deal with. So, if I'm routing from here to there, how many hops is it? You already mentioned that. Stuff like that. You got to think of lower performance. The shift from virtual hardware the physical hardware to virtual systems often causes performance issues. Virtual system saturation causes performance depletion initially if not implemented with proper planning with the right resources. Changing standards. Standards play an important role in running the system smoothly. The administrator may stay abreast with the latest standards better when they are working on the hardware system. You can't really physically work on all the time. How you can learn. Another challenge that comes across is the idea of a virtual network is considered a no hardware solution and it's considered to be costless affair. And it still costs money, so it's not that expensive. A virtual network is cost efficient in the long run, but it does require an initial investment both in terms of time and money. Got to pay people to do this, right? The hardware in the virtual network needs to be more robust than the hardware using a traditional old setup, which is costly. Difficult management. When everything is shifted to a virtual network location, data becomes difficult because both virtual machines and containers can be transferred between servers. Since there are several virtual machines and containers in general, there are several endpoints under the administrator's purview. So it's a lot more to juggle. So moving on. Let's talk about virtual storage. First, multiple physical storage devices pulled together into a single storage device like an area storage. Look, like a network area. Like a storage area network, sorry. That's what this is. I'm pulling it up right now. This is just pulled. Let me go to this PC. Let me see how big is it. I can show you. Like 99 gigs free. Like no, this thing's beyond that. I guarantee you. I can go to mine. It's not gonna hurt anything. And where's my login? There it is. Yeah, see, I just have my stuff in here. I can't go to anybody else's. I guarantee it. I'm not gonna try. Oh, I can try. See, I don't have access. This is very low. But they increment your size if you need more space, and then they just do it automatically. You don't have to do it. So this technology relies on software to identify available storage capacity from physical devices and then can be aggregated as added that capacity as a pool of storage that can be used by traditional architect servers or a virtual machine. It's just this area of storage space. I have a picture of what it looks like next for architecture. The visual storage software intercepts input-output I/O requests from physical or virtual machines and sends those requests to the appropriate physical location of the storage device that are part of the overall pool of storage in the virtual environment. Hopefully that virtualized environment. Hopefully that all makes sense, guys. This isn't really that complicated how it works. The various storage resources that make up the pool are unseen, so the virtual storage appears like a single physical drive, which you just saw when I pulled up. Shared or logical unit number, LUN. It's not that common anymore. That can accept standards, reads, and writes. Just, again, a big storage depot. So, how does it work? This is what it looks like. Computer, storage realized by an application, which was my network drive, which is all pulled together, right? And that's how it goes. Abstract into storage array. So it just stores them in all those areas, whatever it is. How does storage virtualization work? To provide access to the data stored on the physical storage device, the virtualization software is to either create a map using metadata or in some cases using algorithm to dynamically locate the data on the fly. Just how's it going to read it? Is it going to read it through somewhere where it knows it's mapped, or is it just going to look it up through like a math, something with math related, a math expression that quick? Oh, it's there. Leads it to the endpoint. The virtualization software that intercepts and reads and writes requests from applications, and it just stores it. That's all it does. Using the map it has created, it can find or save the data, to the appropriate physical device. So like if I request something from there, I'll go back in here. I'm trying to give you examples because I'm trying to be useful. I'm sorry if I'm not. I'm kidding. Like hopefully you're getting something out of this stuff. If I go here and I'm like, man, I need to access something in the public folder. Let me go to public. There's all the stuff here that's available. Don't worry, I'm not going to get into it. There's something hiding in there, but I need something from my directory. Let me go to my directory. I need something off of my documents. I don't know what I have in here. Yeah, just old stuff. I was like, see, virtual machines that I could have used from ages ago, but we're not getting into it. These are, damn, when I remember making those. I don't even remember making a Windows 95 machine now I think about it. Anyways, I won't have you guys to it. So that's how I can get to there. Using that map, right? It knows, oh, go here, go there, and jump there, go there. Storage virtualization disguises the actual complexity of the storage systems, such as the SANs, which helps the storage administrator, I'm thinking control, perform the tasks of backup, archiving, and recovering more easily than in less time. Cool, easy peasy. 2 more slides to go, 3 more slides to go. Advantages of virtual storage. Faster data migration. Storage mirrors work better with storage virtualization. This data migration is not only faster virtual storage, but downtime is also minimal, if non-existent. Easier management. Cool. Since all management is done via a central console, remember when you guys log into your server, you get that welcome screen, and here's your server dashboard? That's what that's talking about. It is possible for a single person to manage virtual storage even on the enterprise level. Thus, the simplicity of virtual storage translates to lower labor costs. I mean, yeah, but admins are still expensive and not cheap. Like what, 37 minimum, I think an hour is what it is? No, if you're a junior, it's 28 to 32, then senior is 35 plus, something like that. Depending on the position and location. I'm thinking off the top of my head. Flexible storage array options with a wider array of storage options is available. With a virtual SANs, these are transparent to the SANs, meaning it sees and treats these different options as the same. These further add to the ease of management of managing a virtual SAN. Sorry, guys, I can't read like always. Cheaper cost. A virtual SAN requires less hardware, requires far fewer resources to operate compared to other storage types. You can also scale your virtual storage as your requirements grow, so you can just keep adding to it as you need. Like I told you, they just add more storage space people need it. You just slot it onto the drive, essentially. Predictable cost. Virtual SANs cost less than other storage options, even if your requirements change. Adding more space layer will not cost more than the alternatives. That's cheaper to run. Cool. It's how much it'll cost in the future. Add another hard drive. Let's split it up amongst all the people in the space. Better data access. Since you manage all your devices from a central location, users do not lose easy access to your data. If they do lose access, they need only to move to a new virtual machine to keep accessing your data. You can also use any endpoint to access your data. Pretty straightforward. Minimal network disruption. While hit with an issue, only that part of your virtual SANs that is having problems needs to be taken down, while the rest of your shared storage is still able to operate. Wider access. Virtual storage is available. Is available to anyone with the required resources. You also do not need to maintain expensive equipment. Instead, you get an available vendor to provide what you need. All right, guys, almost there. Let me get some water. I'll be back in a minute. So, what are some downsides or disadvantages to virtual storage? Managing the different software and hardware can get difficult when there are several hardware and software elements. It can get pretty hairy if there's a bunch of moving parts, essentially. Storage systems need frequent upgradation to meet the challenging nature of applications and huge data. Yeah, constantly need to upgrade, depending on what you're doing with data. Kind of depends on the industry too. That's what I'm thinking of. Despite the ease of accessing data with storage visualization, there's always a risk of cyber attacks, cybersecurity, and various cyber threats in virtual environments. That is, for data stored in virtual machines, data security and its governance are the major challenges. How do you protect something that isn't real? Who is going to have access? When are they going to have access? Things like that. Are they going to be able to trick you and get access like they did in MGM? Just a thought. Amongst the various vendors delivering storage virtualization solutions, it's important to find a reliable one, as many a time it happens when vendors provide storage solutions but ignore the complexities of backing up virtual storage pools. Vendors tend to not do their job sometimes, guys. It happens, or they're people too. Similarly, they fail in situations when there is a need for immediate recovery of data in case of hardware failure or any other issues. I should put fail, not fall. Let me fix it right now, actually. Fix it. It bothers me. I'm going to just make the changes right now on the fly. Storage virtualization at times can lead to access issues. This can be if the LAN connection is disrupted or if internet access is lost due to some reason. That's kind of the problem with having it virtualized and being on a network. What if the network goes down? What if your internet cuts out and you're at home and you were accessing it? Then what? How do you fix that? You're not going to call your company like, hey, my internet at home's up. That's something you got to fix. If it's on their end, they fix it, etc., etc., etc. There comes a time when there is a need to switch from a smaller network to a larger one. But the capacity of the current one is insufficient. The migration process is time-consuming, can result in downtime. You plan those when no one's around, and it's going to be a huge job. You gotta get it done in a night and a half, or you do it over the course of a Friday night through a Sunday night to a Monday morning, and then test before everyone comes in the office like 5 a.m. praying everything works, because that's a lot of overtime you're going to have down your belt at that point. Additional problems like more significant data analysis, lack of agility, scalability, and more rapid access to the data are common challenges companies face when selecting storage solutions. All right, guys, that is essentially it. And of course, my arrow didn't work like always. So here's what I covered for this part of Unit 3. Managing virtual environment conclusion. Resource allocation optimization. Went over that. Snapshots and cloning. Covered that. EN template provisioning, talked about that, and then we talked about virtual networking and storage. In the second half of Unit 3, we get more into the virtual networking side of things, switches and all that kind of stuff, which we covered a little bit. This goes a little bit more in depth, but don't worry. There's even a GIF with moving parts, guys. So until then, I will catch you in the next one, guys. Hope you're having a good Thanksgiving. Take it easy.